All right, guys, we're ready to start part 2 of our lesson today, which is modeling quadratics with vertical motion. All right, so the equation for vertical motion is right here, okay? So dealing with motion means that you could throw something up into the air and watch it fall down like a ball. It means that a diver or a frog could jump in the water and go down, and then however long it takes them to come back up. Motion can deal with lots of different things, okay? So when we are dealing with vertical motion, things that they're going to ask you for are minimum and maximum height, starting point or the initial height of something, which will be your H sub O, and that's where it will go in the model. The height when an object reaches the ground or reaches the water. Now, please fix this on your paper. This is a typo. It should say Y equals 0. This is where the Y value equals 0, okay? The specific height of an object at a specific time may be asked for. And then your initial velocity is your V sub O. And again, it goes right here. It should be the B value of your vertical motion equation. So let's take a look at an example. Okay, a diver jumps off of a 30-foot high platform at an initial vertical velocity of 16 feet per second. What quadratic function represents the height h of the diver after t seconds of the dive? So they've given me all the information right here that I need to plug in and write the equation of the line, okay? Of course, I've been trying to add pictures for you to go with these word problems. So we've got this diver, he's standing right here. It tells me that this is 30 feet tall. A diver is going to jump up, and at some point they're going to curve their body because they know that they're going to come back down. And I think typically the idea is to make the smallest amount of splash possible, but I don't know a lot about diving. So we need to refer to the equation that was given to me up here. They have given me the initial height of 30 feet, and they have given me his initial velocity, which was 16 feet per second. So let's go ahead and fill those in here. Okay. So height in terms of time equals negative 16t squared. My velocity was 16 t, just t, plus my initial height of 30 feet. Okay, so here's where I got my information. This was H sub O, and this was V sub O, okay? All right, let's answer another question. Now that we have an equation, how many feet above the platform will the diver be at the highest point? At the highest point. Well, let's look at this. What exactly are they asking me to find? Where will the diver be at the highest point? That is right here. And that is a maximum value, okay? So they're either going to ask me two things about this maximum value. They're either going to ask how much time, t, did it take him to get there, or what was the height at that point, okay? So t would be finding the x value of the vertex. H would be finding the y value of the vertex, okay? But I use T and H to help you remember time and height. So how many feet above the platform will the diver be at the highest point of his dive? Okay, so let's first begin by finding the x value. Okay, so if you remember the formula, it is x equals negative b divided by 2a. So we're still using that. So let's plug in. So our b value is 16. Our a value is negative 16. And so negative 16 divided by negative 32 is going to give me 1/2. Okay, so it took him a half a second to get that high up. Okay, now let's find the height. All right, his maximum height is going to be where we have to plug in. We have to plug in this 1/2 to this equation in order to figure out the height. So let's go ahead and do that. Negative 16 squared plus 16 plus 30. And I'm going to go ahead and plug in the 1/2 everywhere. So 1/2, 1/2. And if I go ahead and simplify this in my calculator, I'm going to get 34 feet. His maximum height was 34 feet. 34 feet. Now here's an interesting question that we have to pay very close attention to. How many feet above the platform? Above the platform. So let's come take a look at this picture again to help us figure this out. How many feet above the platform is he? Well, the platform is 30 feet. He has jumped at a high point of 34 feet. So how would we figure out how far above the platform he is? At 34, he's that high above the water, not the platform. So we would need to do the maximum height, which is 34, minus the platform, which is 30. And so the answer here would be 4 feet above the platform. And so that was a little tricky. Okay, they're not just simply asking me for the height. They're asking me how many feet above the platform. So I had to do something a little extra for that. And then finally, how long will it take the diver to hit the water? Again, this is a typo. Would you please change this x equals 0 to a y equals 0? Okay. Now we will learn how to do this by hand in our next unit, but for now we're going to go ahead and use the Desmos calculator. Okay. How long will it take the diver to hit the water? So let's take a look at this image again. Okay. We know that it took him a half a second to get this high up. And so you could estimate and say, well, another half second to get down, that's 1 second. I don't know, I'm estimating 2 seconds, 3 seconds, 4 seconds. I don't know, maybe between 4 and 5 seconds somewhere. Okay, that would be a good guess. But things that go up and things that go down have a different pull of gravity. One, you're moving against gravity, the other is working with you. So we're not exactly sure. So we're going to really need to work this out mathematically to find out for sure. So here's what I'm going to do. I am going to go into our Desmos calculator and I am going to type this exact function. But when I type this into Desmos, I can't use h of t or t. I have to use y equals negative 16x squared. So I need to translate this for Desmos by using my x and y values instead. So here's my Desmos calculator. And here is the equation that I've typed in. Negative 16x squared plus 16x plus 30. Now I'm going to highlight this and I want us to take a look at this picture. Okay, so here it is. Now we can verify by clicking these points that the y-intercept is 30. Okay, we worked out by hand to find the vertex, but look at here, same values. 0.5 is the same as 1/2, and then the maximum feet was 34. So if you were going to do this via Desmos, you would need to have known 34 minus 30, and you could have still gotten your 4 feet for your answer for the last question. Okay, so the diver is currently right here. He's going to jump up and then he's going to fall back down. So the point where he hits the water is at this x-axis. Once he hits the water, obviously you can see that the line continues down further. That's just him going under the water, okay? So let's click here. This is my x-intercept. Now there are 2 x-intercepts. We have to be very careful with our word problems that we choose the correct one. If I jump and somebody starts clocking me, would it make sense that time would be a negative? And the answer is no. So typically with these word problems, we want to find the positive xy intercept value, okay? And so in this case, we estimated approximately 5 seconds if we used the measurements for each 1/2 of a second. But the answer here is actually 1.95, okay? 1.95. So let's go back to our notes. So we did this in Desmos, and we got 1.95 seconds and 0 feet was the height. Okay, his height above the water. Alrighty, so that is how we work all the way through a vertical motion model. Let's do one more example, all right? One more. So if you're following along with me in the guided notes, we are now on example 5. A football is kicked into the air. Its height in meters after t seconds is given by this formula or equation. So they've already given me the equation. What was the height of the football when it was kicked? The height of the football when it was kicked. Okay, so there are 2 different ways that we can go about all of these. I'm going to show you how to do it by hand, okay? So when the ball was first kicked, how much time had passed? Well, the ball is sitting on the ground on a tee, and this person has not yet kicked it, okay? So there has been 0 time that has passed. So I'm going to use t equals 0, all right? And I'm just going to plug that in. Negative 4.9, 0 minus 2.4. So let me plug in my 0. Okay, and now I'm going to go ahead and simplify this using my calculator. So if I do negative 2.4 squared times negative 4.9, I'm going to get negative 28.224. I'm just using my calculator to type these in. And then if I add these two together, okay, negative 28.224 plus 29 will give me 0.776 feet. Okay, so that's how I do it by hand. I just need to know to plug in that the time that has elapsed is 0. All right, so let's take a look at our Desmo calculator really fast. I'm going to turn this one off. Now this blue line currently represents the football and the equation that we're currently working with. And so if I look right here at the y-intercept, I get 0.776, okay, which is the same answer that I got doing it by hand. All right, the next question that they're going to ask me for is what is the maximum height of the ball and at what time was the maximum height reached? So you can also do this here. Right here is the maximum height of the ball, 29, and that was reached at 2.4 seconds. Let's go back and see how we're going to find that here. Okay, so remember negative h comma k, that's my vertex. Since I'm in vertex form, I can just look at this and identify the vertex. Negative 2.4, remember when I take this out of the parenthesis, I change the sign. So it's going to be 2.4 comma, and then the y value is 29. Which is exactly what we got in that Desmos calculator when we looked at the height, okay? Or the maximum height, rather. Part C, let's look at part C. How high was the ball after 2 seconds? After 2 seconds. So in this situation, I need to plug in a 2 for the t value. So negative 4.9 times 2 minus 2.4. Okay, so 2 minus 2.4 is just 0.4. 0.4 squared is 0.16 times negative 4.9. So if I multiply these together, I'm going to get negative 0.784. And then I just need to add that to 29. Excuse me. And I'll get 28.216 feet. Most problems would probably just ask you to round that to the nearest whole number, but I'm trying to be extra specific. So that's how you could do it by hand, plugging in the value for time equals 2. Let's go look at the Desmos calculator and see how we could have done it there. So if I want to know the height of the ball at exactly 2 seconds, I can find x equals 2 and try my best to click exactly there. But if you notice, I'm at like 1.99. And then when I move it slightly, I'm at 2.02. The best way to get it exactly where you want it to be is to type it in, x equals 2. And then you can just click on that point. I get 2.28, 2.2, oh, I'm sorry, 2 comma 28.216. 28.216, and that's exactly what we got when we did this by hand. 28.216. All right, now here's a question. Was the ball still in the air after 5 seconds? Was the ball still in the air after 5 seconds? So let's do this by hand first. Again, we're going to plug in t equals 5, okay? Minus 2.4 squared plus 29. 5 minus 2.4 is going to give me 2.6. I'm going to square 2.6 and I get 6.76. All right, let's bring down everything else. 4.9 times 6.76 is going to give me negative 33.1. And then negative 33.1 plus 29 gives me negative 4.1. So do you think that the ball was still in the air after 5 seconds? Okay, let's take a look at our Desmos calculator. So let's change this x equals 2 to x equals 5. All right, so I want you to think about, in this model, where is the ground? Where is the ground? The ground is this x line, this x equals 0, okay? So the ball was at negative 4.124. This was a little more specific than us on paper. So if I follow the trajectory of the ball, it was kicked off a tee, it went way up into the air, and then it hit the ground right here. And so at 5 seconds exactly, it would be under the ground. So obviously the football doesn't go under the ground, it just hits it and bounces. So the ball was not in the air at 5 seconds. It had already landed at 4.8 seconds. Okay, so our answer is no. No, it is not. Okay. All right, guys, so that is our 2 examples that we're going to go over that have to do with vertical motion. All right, so these notes are important to have. Just make sure that, again, you change this x equals 0 to a y equals 0. That was my typo.